What we have done is in our research unit is that we went the other way around and we said let's be smart and let's be analytical around our architecture. And I'm not going to spend a lot of time, I shared that with the guys last year, but we've got a fundamental concept of how we see process going in future. So we've got a future vision of architecture, of process and how it's going to evolve in the organization. And we talk about smart processes. That means it is a process that will deliver what the customer wants, but it can also adapt to the need of the customer. So through very simple control theories, you can build a process that will adapt to the need of the customer. But hence, in order to do that, you've got to be able to track the footprint of the process, you've got to be able to analyze analytics around that, and then you've got to be able to understand what these things tell you. Whether the customer wants now this or whether he wants to do that. So that is our basic design of architecture that we use to understand where these things are going to go towards. And hence we had to formulate a different concept now in architecture. So I've created the concept of a fractal, business fractal, based on the work of Mandelbrot, where we talk about fractal geometry. What we're basically saying is when I look at the system or that fractal or that picture that I get from the system consists of a pattern. Shape it's round. It consists of content. It's green. It weighs something. I can do something with that. It consists of memory. That means if I throw this apple up and down, it's now in motion. And then it consists of something called volatility. So if I hit somebody with this apple, what is going to happen? Okay. Yes. So what we've done is we've taken a static architecture, which is the apple, you can see it, the color, and we start to move the architecture around. It's like, you know, what happens if this thing moves? There's also some funny stuff can happen with this. And then we've created an understanding of saying that you've got to expand your dimension around your architecture. You can't just have a static view in your architecture. What we've done is, just quickly want to show you, so what we are focused on is when we look at an architecture, of a system, we look at the analytics of the system, so hence we are trying to extract the actual behavior or footprinting of that process or that object in that particular system. Now, at a university, they don't give us a lot of money to do research, so we don't get 10 million or 15 million or $1,000, so we've got to do whatever we've got to do. So what we've done at the department is we've started to create, we've used an open source stack through which we can process all the data analytics. So we can process 30, 50, 60, 100 million records, and you can say, what does this tell me about the architecture? And then what we do is we put this stuff into simulation models, so we try and understand now, if I take an apple and I throw that apple, what is going to happen to the apple? So we've created basically a methodology to try and understand how do we make the architecture dynamic. And if you talk about how we solve complexity. I'm so glad Paul mentioned this. Because I can't tell you about the design if I don't mention people. So as I threw that plane into the air, it was kept in the air by the force that was created by its movement through the air. I always say people create the lift of a process in the organization. And I took funny pictures, you all look very sad. I've got some family. I've got some pictures of my family here today, so to show you. But people can do some very weird and wonderful things. So don't forget, whatever we do, we work with people and they can do funny things.